Now, let me move and introduce Satish, and Satish is going to give you a real-life demo.
Good morning. I'm Satish. I take care of account management for CloudByte. I'll walk you through the demonstration that I had set it up. You can sit if that's easy. Pardon? You can sit. Okay. Thank you. Take that chair. Easy. So this is the Sorry. Okay.
Tech support. All right.
Yeah, this is the dashboard, the main dashboard of Elasticenter. This is the global management console where you can get a complete view of all the storage that is managed by a single management console. We have divided this management user interface in 3 different parts: the physical infrastructure, virtual infrastructure, and then the dashboard, which gives the complete overview of all the managed storage. Physical infrastructure consists of sites. These are different storage systems that are distributed globally. For the demo purpose, I have a single site, but you can have multiple sites configured and managed by this single console. And each site consists of multiple HA groups. These are high availability groups. As we talked about, there is no limit on number of HA groups under each site, but within each HA group, there can be there can be 4 nodes. The 4 nodes work in conjunction as a complete HA group. So even if 3 of the nodes are down, the storage is accessible, and you can work perfectly fine. In a traditional storage, we have seen 2 node HA groups, but we can scale up to 4 nodes here.
Is that in pairs? Is it 2, 4, or is it 2, 3, 4?
It's all pairs. It can act in active-active or active-passive, different types of configurations.
It could be 2 or 4, or it could be 2, 3, 4.
So it could be 3.
Yes. Okay. It can be 3. Yeah. Under nodes, these are the pools. Here, these are.
So in order to have access to all that data when 3 of the 4 are down, then you effectively have replicated all the data that are on any of the Elastic stores to all the other ones. Is that correct?
Actually, all these 4 nodes are sharing the underlying storage.
So the underlying storage is shared across all nodes? I thought there was some geographic dispersion that was capable here within a group.
They are shared across all nodes through this AS cable.
I think there's also a replication for geography, but it's not clever safe like dispersal.
Okay. Let me jump in. So we can you see this? Yeah, this is kind of tough. Go ahead. Let me move this. Yeah.
We like your
whiteboard.
You're good.
So, okay. So, what's different about CloudByte is most vendors can have 2, but we can have up to 4 nodes in an HA group. So this is, assuming I learn how to write 3. And if this is the storage, the pool of storage, you would define, they'll have a link to the pool, but this would be the primary for this. This group would be the primary for this one. And then if, let's say this node went down, this would just take over. Does that make sense?
Yeah.
So it's kind of typical HA.
And you can have quad port to the storage. Is that how it works?
Yes.
Okay.
Yeah. And so
Pool is owned by one of the controllers, nodes, however you want to call it.
Well, the concept of active-active is this is the primary. This would be active, right? So this would be active in this term, this would be active for this pool, it would be passive for this pool. That's one configuration. Now, you can...
And within a configuration or a pool, it could be RAID protected, RAID 1, RAID 6, whatever, depending on how the customer needed from a TSM perspective.
Yes, yes. And one of the advantages of ZFS that I really like is what they call RAID Z3. So what RAID Z3 gives you is, let's say you have 4 disk drives here. With RAID Z3, you can lose 3 disk drives and still have full access to your data. So we're matching RAID Z3 at the controller level as well.
You mentioned that a TSM can move from pool to pool, no, group to group. So each of those is effectively a group. It's even more than a group. It could be multiple groups within each of those blocks.
Yes.
Yes. So you have a lot of flexibility.
And the TSM can move from one to another if necessary.
Yes. So
it's one single pool across all 4 nodes.
Yes. Yes. And you could also, now, you could also, let's say that this is San Francisco and this is London or whatever. You can have another set here. And you can actually move a tenant storage machine from here over to here. So let's say that 3 of these nodes were down. You could actually move their storage machines temporarily to here. Take care of it, and then move it back, when the nodes came back up.
So the geographic dispersion is not across an HA group, but rather between 2 HA groups.
Between clusters, yes, HA clusters.
Between HA clusters, yeah.
All right, I got you. I'm good.
And depending upon your hardware and networking setup, you could, again, this is kind of more pure ZFS stuff, but you could define a cluster that is geographically dispersed. Right. But would you want to do that? Depends on your latency and so on. So does that make sense?
Yeah.
Okay. Sorry, go ahead.
So under the pool, it gives analytics in terms of what is the total capacity, what is the capacity provisioned, and what is it used. As Michael mentioned, we support thin provisioning. So you can clearly see how much of the provisioned storage is being used, and if you are reaching its max, you get alerts. And this screen gives the performance characteristics of how many IOPS is being used by this pool. And we have all the historical data. When you go into the mode, you can get all the historical data of pool utilized IOPS. And moving on, these are the tenant storage machines. These are virtual storage controllers. You can configure each tenant storage machine for each of your applications or group of VMs that are accessing the storage. Under each tenant storage machines, we have storage volumes. So, for example, this tenant storage machine TSM1, I have configured 2 storage volumes. Both of these are iSCSI volumes. If you go into the storage volumes, this shows, this screen shows all the storage volumes and which tenant storage machines those storage volumes belongs to, what type of protocols these storage volumes support, and on what interfaces these storage volumes exist. So, for example, I have configured this TSM1 volume 2, which is a iSCSI storage volume. And I have started running IOs on this iSCSI storage volume. So the analytics that you would get in terms of capacity, that is how much storage has been assigned and how much is being used, as well as in terms of IOPS, how much IOPS have been provisioned for this storage volumes, and what is being used on this storage volume. For example, here if you see, I have provisioned around 3,000 IOPS for this storage volume, and this green line shows from the application what is the IOPS being consumed on this storage volume. So if you see, I have started this workload few minutes back, and you can see that the IOPS being consumed by these applications has gone up and is getting guaranteed at 3,000 IOPS. So that's what
the quality of service is. You can restrict how much actual activity IOPS on a per volume basis.
Yes, on per volume basis, as
Volume
well
is
as
effectively assigned to a TSM.
pardon.
A volume is assigned to
A TSM. Yeah. So yes, it pulls, the total IOPS numbers, it pulls from the TSM. It's being shared by the storage volumes. Yeah. And the quality of service, the policies, you can set dedicated for each of the volumes, or you can group multiple volumes into a single policy, and that particular IOPS can be shared by a group of volumes.
How can you know what is the maximum amount of IOPS you have available on the storage?
Okay.
You run background tests on the storage?
No, when you provision the pool, our software goes and queries the backend hardware, the disk array, and shows what is the total IOPS available from the storage. So based on the kind of disk that is.
Okay, I'm kind of concerned by queries the backend disk array, because I wasn't aware that there was an SMIS counter for how many IOPS I can provide, and even if there was one, I wouldn't trust EMC or NetApp to actually deliver whatever that counter told them they were going to get.
True. For that, you can also go and set those IOPS values. We provide what is what we estimate from those from the backend disks, and if you trust that your backend can deliver much more, then you can go and set it here. Under each pool, you can set what is the IOPS that you expect from that.
But that's the profile you're using, that 60/40?
Yes, this is the profile we use. Yeah.
4K?
Yes, this is the workload profile that we use.
Yeah, you need to test.
Yeah.
I need to say, here's a new pool, and before you actually put data on it,
Go run a test.
beat it up for a couple of hours, and then come back and go, this actually will provide this many IOPS.
Right.
Yeah, and
you get with your customers on the accuracy of what they're seeing in that area? I mean, are they telling you guys are way over running this, or you're under, or
Particularly in
are you being conservative on purpose? I mean, how are you getting at that metric in a way that makes real world sense?
particularly in nearline SAS and 10K RPM, 15K RPM drives, we are pretty close. In terms of SSDs, the IOPS vary a lot.
Yeah, spinning disks are easy.
Yes, it's reasonable. Yeah.
Greg knows that.
Yeah, so I think the opportunity is to be more precise as you go forward, and I think everybody recognizes that disk is pretty predictable. Vendor to vendor, it's a pretty predictable profile. SSDs is the new field to say, how do you believe them, whether it's fresh out of the box or conditioned or those sorts of scenarios. So to your point, we take a relative conservative approach to it. And the reason that's okay is by being more conservative, you're going to have most likely IOPS to use in the future. So when we tell our customers, don't worry about being right on the first one, because you now have a rich set of management tools that's going to tell you how conservative you were based upon the workload you're running. Because there's two factors. It's not just the storage infrastructure that you want to be conservative, it's the visibility of what really is the workload that's being demanded by a particular application. So when you put those two together, the dashboard tells you how much additional performance or capacity you have to then be able to provision out for other types of services.
Given those constraints, I completely agree you have to be conservative. But does that mean that you're not able to really solve 100% of the initial problem, which is not having too much overhead, not having to throw lots of overhead in the system because you can't accurately describe the full capabilities of the system? So in some ways, there is still going to always be that gray area where you're going to have to basically say, we really don't know exactly how far we can push this thing until we actually hit a wall.
I think
So we have to basically back off that wall so we don't negatively affect customer workloads.
I think it's slightly different, which says you're absolutely right? But there's two sides that have to work together, which is knowing exactly what a storage system will deliver. And if it's a sort of disk-based system, you probably got some good predictability of those capability. This SSDs are a wild card.
Well, there's tons of variables that go into that.
Correct. And what I'm saying on the other side, the variable is what's the workload really look like? And I think as we talked earlier, we're thinking, oh, it's a web services application, therefore it's this kind of profile mix. The reality is it's a dynamic mix. And so really what's that going to be? That's where the tool set, after you sort of have gone through it, you go, now I know how conservative I was or I wasn't.
And this is going to tell you what kind of, I didn't see this screenshot. Is this going to tell you what you have remaining? Like, we see 10,000 IOPS, you're using 8,000, therefore there's 2,000 remaining?
Yes. So that's what here it shows.
Okay, I didn't.
See this,
Got it.
the orange line shows that, you can go up to 6,400. That is the requirement from the application.
Very cool.
And can I jump in? And also, this isn't static. So one of our drill downs, we're going to talk about how we have heuristics that essentially tune, the number of IOPS can change, and we have a self-tuning mechanism. So it can essentially throttle down some storage virtual machines, give more performance to others, what we call grace performance.
Okay.
And we're going to make that subject of a drill down, but very quickly, let's say you have 3 virtual machines, 3 tenant storage machines, and 2 have 5%, and they're pegged at 5% of your IOPS capacity. The other one can start at 5 and have grace all the way up to 100%.
Can you,
right? So we can actually
the settings of the limitations. How do you set them? Is it hard limits on IOPS? Is it percentage of the usage? The oversubscription. So can we have a little bit on that?
It's simple. You either do a hard limit or you do a limit plus grace, what we call grace, and that's a key factor. So
both on IOPS and on percentages. So can you do a hard limit on percentage of the total capacity, or do you hard limit on the total IOPS?
Yeah, we hard limit on the IOPS.
Okay.
Right now we are
which are manually entered or queued by. I mean, if you do a hard limit, somehow if it's not measured the actual capacity, you're not going to use part of the capacity.
Correct.
Correct. And that's why grace is really useful.
I think you answered my question. It's mostly science, part art, getting more and more scientific every day.
Yes.
Correct.
Is that an accurate statement? Okay.
Perfectly.
Absolutely. There has to be someone tuning, someone smart, working on this kind of stuff, as there is today.
So is CloudByte a software-only solution that's sold to the customer, or you sell it as an appliance, or?
We sell it as a software-only solution, which means we're engaged with systems partners who bring the x86, JBODs, disk components as part of that element of how you build the solution capabilities. And part of the reason it's been very well received by those partners because they're looking for software value add to the hardware business. And 2, to be frank and honest, we don't add any value to those components, so adding a step in the chain moves against being the most economical model, right?
Right.
So that's kind of how we're delivering the pieces to it. I'll add one sort of comment that I'm sure Satish will go through and show in the demo here is that, sometimes our customers making decisions is the hardest thing they have because they've got enough choices and capabilities. But to the question, if I have a new volume I want to add and it has some capacity and some performance characteristics, where would I put this is a question, right? But CloudByte gives you recommendations to allow you to say, here's where it would fit. It would sit on storage node B versus storage node A, and allows you to try and do it. So we're trying to take complex issues and simplify them, whether they be performance or simple manageability elements.
Now, what about on the client side? If I'm consuming it as a tenant, I obviously don't care about how much the array can do or not. I want to make sure I'm hitting my SLAs. What do I see at that point?
So what Michael was saying, you have really all the levels that'll go down, and I think Satish will go through that in the demo a bit, is that essentially as a service provider, I can provision it out to each of my clients. Mm-hmm. My client can then provision it out to each of the projects within the elements. All they see within it is whatever is passed down through that sort of hierarchy. So as a client, you're going to see what you have asked for, what's your capacity, what's your performance, and how you're doing against its allocation. Okay. If you need more, that's when you say, hey, I want more services, or, geez, I've got too many services. Can I give some back to the pool? And there's simple ways to be able to, as I say, get more, but also get down less. So the idea is you're only getting exactly what you need by looking at the the performance metrics that tell you what your application is demanding over time.
Do you put requirements on the service providers for like how much cache or how much DRAM is going to be in a server or things like that? I mean, obviously you mentioned the quad ported backend kind of thing, but besides that, do you require a certain amount of DRAM?
Yeah, we size based on the workload.
Based on the workload?
Yes, based on the workload.
And a workload
As well
is
as-
how many disparate applications do you
Yeah,
want to
yeah.
run? So there are
General
some
sense, yeah.
elements to that we give them the tool sets to sort of go figure and be able to figure out what's the right size server that's going to handle the diversity of what they believe they're trying to set up to be. A lot of small workloads or a few big workloads, those all things get into it.
Is there QoS beyond the limits? So, clearly, I'm going to overprovision. I'm going to have 8,000 IOPS available. I'm going to install 10 VMs and tell them they can each have 2,000 IOPS. So I'm going to limit how noisy a neighbor
You got
can.
to thin provision the IOPS. Is that what you're going to do?
Of course, yeah.
Well, you can have limitations, but is there also reservations?
Well, the question, then becomes, okay, so we've got limits. What happens when we start hitting the aggregate limit? If I do that and I've said, okay, I've got 8,000 IOPS available and I'm allocating 12,000, when I start hitting 7,000 or 8,000, is there some way to prioritize to go, well, when these guys are noisy, let that guy play his guitar, but that guy playing the drums, shut him up?
You can tune them down, absolutely. And you can tune them down with absolute numbers and policy capabilities. Because let's say you've got a guy who needs 2,000 IOPS, but he's bursty. He only needs it for a short period of time.
Right. Well,
Right?
like
then you
everyone.
say, let me tune you down to what you really need and give you an element of grace that gives you ability to burst out of that using the concept of essentially thin provisioning that says not everybody's going to be bursting at the same time, but I'm going to give you that quality that you're expecting through those sorts of capabilities. Okay. And that's where all the smarts is. That's where you need that rich data sets that Michael was talking about, is sort of the performance algorithms and metrics feeding back to you to say, what kind of application do I have? How do I best manage it and use the tool sets to get the most out of that storage infrastructure?
And all of this QoS is on the ZFS volume level?
Yes.
Okay.
The ZFS volume level.
I mean, I really want it at the VM, I really want at the VM level. I want it, and the
For NFS protocol, we can do at the VM level also.
At the server VM level?
Yes.
That's for server VM level or the tenant storage machine level?
at the tenant virtual machine level.
Yeah.
I want to say
is.
this tenant SQL server gets this many IOPS.
Yes, we can do
Yes.
that. Yeah, 100%.
Okay.
Yeah.
Because
Yeah.
if it's at the volume level,
Right.
Yeah.
that's just not granular enough.
Yeah, agreed.
For all protocols?
Well, it's got to be through NFS because they don't have
NFS.
visibility.
Yeah.
Yeah, no one does. And by the way, the use case to talk, it's always very theoretical talking about allocations and stuff, but the best use case I've found is at the end of the quarter and end of the year, the CFO's team doesn't need a lot of cycles most of the year, but end of quarter, end of the year, they need all that they can
Right.
get. And they pay everyone's bills. So you want to...
I used to run IT at a college.
There you
and
go.
So then Scott did
There
at
you go.
several colleges.
Yeah.
Registration week, that application needs every bit of resource you can give it, and the other 13 weeks of the semester, it sits there doing nothing.
Exactly, and we finally provide the flexibility to handle that kind of stuff because they can grace burst and take up all the resources, and then you throttle them back down the rest of the year, rest of the quarter.
So the open question of what happens when you start to run out of performance, let's say, right? Capacity, we all know you add a disk. Performance, the same thing, right? Add a performance-oriented disk. It could be a 15K, it could be whatever that performance increment that's needed, add it to the resource pool, and it'll be used and allocated.
Do you provide guidance on that within the tool?
We,
What I have to figure out is, do I need to add a 15K or an SSD?
That we don't actually provide quite yet. We work more on the configuration side, but that's part of our growth, which is just saying, okay, you get to a certain stage, what do we recommend you do to that next sort of elemental stage? Most people have an idea of what they believe their performance is going to be, but I think as we talked about in SSDs especially, we want to better profile different vendors or different types of SSDs in different ways to see how we can best optimize what they are, because there can be a wide variety rating of an SSD that's cheap might give you X performance. One that might be a bit more expensive might give you X plus Y performance. How could you pick and choose those sorts of scenarios?
I'm just thinking if I'm managing a pretty reasonable sized environment and I'm trying to keep my OpEx personnel costs down.
Correct.
I don't want to have to look at every bottleneck and say, gee, do I need to put a 15K drive here or a flash drive, or have to like go through this whole process every time.
You're right.
I'd like the array to tell me, because it has all this data, this is what we think you'd probably do to solve this bottleneck.
You're absolutely right, but remember, you're not managing it at the physical level. You're managing it at the logical level. So you're going to see at the macro stage, what's my capacity, what's my performance utilization overall, with the ability to drill down into the different areas. It's the TSM's job to manage to make sure it gets the performance it does. So if a TSM isn't getting the resources that it thinks it needs in the pool it's in, then you get the alerts that says, I need to move to a higher performance pool and be able to do it. And you say, click, OK, and then migration happens in the background. So the management of the ongoing sort of infrastructure is extremely simple, because there is no plug and reconnection. Everything is done at the TSM level.
Okay, moving on. For each of the storage volumes, we provide detailed analytics in terms of what is the throughput your application is getting, what is the kind of IOPS that is getting realized, as well as what is getting throttled. And we also provide insights on the workload, what is the kind of block size, what is the read-write ratios, the application is driving data, as well as what is the cache hit efficiency. And what is the latency the application is seeing on this storage volume. So all these details are provided on a per storage volume basis.
And then Satish, so to answer your question, sir, so if you would over provisioned all of your virtual machines, it would show up in red there, right?
Yes, that's right.
So can you go back to that for a second?
So I'd have to drill through all these to find where I'm not hitting cache, and then supply cache to
go
that
back
storage
up.
node.
Yeah, so that was throttled. So that would, if he over provisioned, wouldn't it show throttling there? That's where he would know that he'd over provisioned.
Yes, that's right. It'll get throttled here.
Okay.
Yeah. So you'd be able to tell you'd over provisioned, and you can adjust.
Okay.
And I want to show a demo on how the IOPS are guaranteed for each of your tenants. In this demo, I have configured TSM1 Vol 2 with 3000 IOPS, as well as TSM2 Vol 1 with 4000 IOPS. These I have mapped these two storage volumes to two of the clients, which is running the regular IO test using IO meters. So this is one of the IO meter. I have two VMs which is running IO meter on these two volumes. This IO meter is mapped to TSM1 Vol 2, which is provisioned with 3000 IOPS, and as you can see, this particular IO meter is guaranteed with this 3000 IOPS. And also I have another VM which is configured with the configured with the other storage volume, which is provisioned with 4000 IOPS. So if you see here, this IO meter is guaranteed for 4000 IOPS, and the workload is 4K block size. And I also want to show you how we can dynamically select different performance for each of these volumes. So for example, in TSM1 Vol 2, instead of 3000 IOPS, I will increase it to 3500. While this workload is running, we can dynamically change the performance characteristics of each of these volumes. So here I am changing it to 3500 IOPS. So if you see here, if you see this particular VM, now it is getting 3500 IOPS, and the 4000 IOPS for the other volume is not impacted at all. Meanwhile, we can go ahead and change this 4,500 IOPS volume to, maybe 4,500.
I noticed it's pretty latent. Can you make the latency better on that? Like that
Latency is based on the storage pool that you choose. So if your storage pool is of 15K RPM disks, then you get a much better latency. If it is a SSD, then you get latencies of that SSD pool. So that's how the latency is controlled. So while you are provisioning the pools for these storage volumes, software automatically says which kind of pool provides you the latency that you want. So that's where you can configure what pool your storage volume sits on. So here for this volume,
that's one of the decisions you make when you're sort of setting things up, which is what's your expectation on IOPS or bandwidth or latency.
I just want to see that number go down and do something. The 15 down to like a 2 or something.
That didn't happen that fast, because if you're moving data from one specific group.
So if you see the other VM
it's
now,
actually one of the things people forget. It's like, oh wait, this workload is on a slow storage system, slow storage pool. Let me give it more performance by moving it to a fast storage pool, but that puts more of a load on the slow storage pool to migrate it.
Correct.
And so you have to make things worse to make it better in that kind of environment.
so now the other VM is getting the newly provisioned IOPS. And also I want to show, Michael was talking about enabling grace. If there are unused IOPS in the pool, then when we enable grace for a volume, then all the unused IOPS will be used by that particular volume. For example, let me enable grace for TSM1 Vol 2. And you can see, all the remaining IOPS will be utilized by this pool.
But to Howard's point also, you can share grace. So you can say, okay, I have available IOPS. I want them between these different applications. So there's policies, ways to be able to also set up flexibility. In my simple terms, I think of it as overdraft protection. Do you want a little? Do you want a lot? And in the service provider world, that allows them to monetize it. It says, I'm going to give you additional flexibility to time what you need. But if you need a lot, that means I'm reserving capacity and I need the remuneration that matches. And it gives them the tool sets to provide exactly what you want. And again, coming back to, if you know your performance dynamics and the characteristics of an application, you can determine whether is that required or not required, or if you need certain things, as we talked about, registration day, seasonality, you want that capacity available for you. It's a good way to balance, I'll call it performance from an infrastructure and monetization for putting that in place.
So once we enable grace,
but there's no performance floors or prioritization in the current QoS model.
Meaning zero?
Well,
minimum
some other vendors who shall remain nameless, because you're like the fourth vendor I'm aware of who does storage QoS. I think storage QoS is a great idea. So please don't get me wrong in going, you didn't go far enough. You're only ahead of 99% of the rest of the world. But when I define a workload, I'd like to say, make sure this workload always has X IOPS available, limited at Y IOPS. And then when the system as a whole is short of IOPS, this guy should get before that guy does. So I'd like to have, you do ceilings, which is a good thing.
Right.
I'd also like to do floors and priority.
So I have customers actually doing that, who is moving their storage service up to 100 IOPS as sort of the base element.
Yeah.
So they're trying to say, I want to compete with everybody else, but I'm going to give you a guaranteed 100 IOPS minimum floor. And then all the other things we talked about is you can buy up, you can buy flexibility, you can buy different elements for them to be able to do that. So they can allocate that out for that capability.
so as you can see now, once we enable the grace, all the unused IOPS from this pool is being utilized by this VM. And you can, as we talked about, having multiple accounts created for customers. You can create multiple accounts here, and each account can have its own administrators. We provide 4 levels of administration. One is super admin, who can manage the whole whole storage, CloudByte storage, and then site admin and account admin. All these admins can manage storage that's provisioned for them independently. And I also wanted to show some of the features that we provide for the TSMs. We provision, we support unlimited number of snapshots, and we also support scheduled snapshots in terms of from few minutes to hours. And you can
within a test, or the snapshots
with
at
all
the volume or the file level.
At the volume level. And you can also create a disaster recovery TSM. This TSM can exist on a completely different geography. That's in case one of your storage goes down, you can immediately fall back to the disaster recovery site.
And creating that is as simple as copying it and essentially, moving it and saying, I want a destination. So again, since the TSM has all the definitions of policies with it, it makes it pretty easy to make those things happen.
Creating the DR TSM doesn't actually replicate the data. It just creates the policy group and all that stuff out at the other
Becomes a new destination, correct.
Right.
And you can also migrate it if your pool is not capable of handling the workload, or if you want to increase the IOPS available to your TSM, you can migrate it to a new pool. So these are all all standard enterprise storage features are supported by our product.
And in Snaps, you support read-write, clones, kind of things, or
yes, we support snapshots and clones. If you see here. So these are some of the snapshots that I created yesterday. And if you want to clone it, just click this and it gets cloned as a new volume.
Is there anything from, like, let's just say VMware, from that perspective that you can't do or you have to do differently, such as snapshots, storage vMotions, clones, replication?
QoS.
Anything? Like, can I do everything on vCenter from the vCenter client that I could always do before?
Right. Can I answer the question, Satish?
Go ahead, Muma.
Right. We are having a development work currently in progress to integrate with vCenter APIs, using which you can take a VM level consistent snapshot, or in the VMware world you call it as crash consistent snapshots, right? Also, we are integrating with the site recovery manager, meaning if you can take the snapshots at the VM level, you get an equivalent storage level snapshot, and when you do a disaster recovery management at the VMware, the corresponding storage gets activated in the remote site. So we're going to have a completely transition as far as the snapshotting, cloning, and the disaster recovery is concerned with respect to VMware.
So right now it's not. So let's say I run backup like Veeam or PHP Virtual or something like that. That won't work currently? Because they use snapshots.
You need to have the scripts put in manually. With the integrated plugin, you will not even need to get into the Elasticsearch console. You can actually do them right from the vCenter. once it's done, and it's only a couple of months away.
I'm sorry, I kind of missed half of that.
Can you repeat, Oma? You were breaking.
Right. In the absence of integrated plugin, we have the REST APIs available at the Elastic Center. You will need to configure using the APIs of vCenter using some scripts. So even today, with the available production version of Elastic Center, you can get consistent snapshots. So, but we are trying to make it easier enough in terms of providing a seamless plugin into vCenter.
So you have to do it manually, essentially, right now. Until
Yes, through the REST APIs, it can be integrated. Yeah. Okay, so that completes the end of the demo.
How do you initiate replication of the data across geos and stuff like that? So if you wanted to support true disaster recovery, you'd have to have the data at the other location. Did I miss that? Is that something? No.
So this is where you create a disaster recovery TSM and you schedule in a different site. Right now I have a single site here, but when you have multiple sites, you can select on which sites you want the disaster DR TSM to be provisioned, and once you provision this, then it starts replicating.
And it's a scheduled replication, or it's a asynchronous replication, or synchronous, or
it's a asynchronous replication. Yeah.
Today it's asynchronous replication.
Right.
Yeah.
There's no bandwidth or footprint optimization here, right? So there's no deduplication compression involved. It's just one block on the other side.
Umar, you want to talk about it?
Uma, during replication, do we replicate the deduped blocks, or is it undeduped data that we replicate?
It's a block level incremental replication. So we do the deduped blocks to the others.
Is it data deduped?
Automatically tries to reduce the amount of data that needs to be transferred over the wire. So it's already at the block level. The block level data is already deduped.
Oh, I didn't hear
It's the first time I heard the word dedupe in the whole presentation. Is the data deduped on the back end?
Is this a deduplicated storage or
Well,
not?
it's a feature of ZFS.
Yeah, so ZFS supports compression and dedupe. So when we mentioned earlier that we fully support ZFS, that's one of the assumptions that brought it. So ZFS has got great compression and great dedupe.
Okay, I'll give you great compression and mediocre dedupe.
Fair enough. Yeah, I would take that.
So if you see the volume here, you can go ahead and switch on the compression as well as dedupe here. And this dedupe that ZFS supports is a inline dedupe.
Fixed block 4K.
Oh, and variable block size, right?
And a variable block size.
Yeah, so we have variable block size 4K up to, I think, 1 meg. Uma, what's the maximum block size?
1 meg.
1 meg, okay. Which is standard ZFS, right?
Any other questions?
On the analytics side, do you use the trace tool that was ported on FreeBSD, or are you?
Great question. So Uma, do we use dtrace? Do we use the trace tool that comes with FreeBSD? What do we use under the covers?
We use dtrace heavily inside.
Okay. So dtrace is part of ZFS associated.